Okay, welcome to our next podcast. We're going to cover a few things today, including a quick comparison between what will be coming out with the EMPATH 9.0, just a quick overview of one of our betas, and then comparing that data directly to an Empower system. And then I'm also going to show you what we're working on in Empower that will be available in the next couple of weeks to Empower users. So this past week, there'll be a set of articles out in that I'm announcing in the newsletter. They're already on the Reliable website, reliamag.com, and a few other things. But I was appointed as the CIGRE regular member for A1 for the United States this last year. And I attended my first CIGRE US meeting, or the US National Committee meeting this last week, related primarily to the grid and challenges associated with the grid. And it was enlightening. I was attending in order to gather data for the work I'm doing in IEEE, and also under American Clean Power as the chair of standards for wind, solar, and energy storage. And it was interesting from the perspective that I was hearing similar concerns as to what we were seeing in the power generation side with distributed energy resources, or DER as we call wind, solar, and energy storage, of course. And then all the other alternative energy approaches. We discussed small modular reactors. We discussed a lot of other things. What was interesting is that the primary conversation around the unpredictability of power generation, which was known, accepted, and viewed as we have to move forward with that type of generation by the transmission folks, the actual engineers associated with large or bulk transmission and distribution, as well as local distribution. But the conversation around hybrid and electric plug-in vehicles, basically, and other electrification stuff really kind of slid down a little bit as people realized that data centers, cloud was a big move, right? That took up a large chunk of electric energy generated early on, but it was steady, and that was brought up, meaning you had a steady load, you could project it, predict it, everything else, and the equipment was built to handle it. And you have to remember that a lot of the equipment out there that makes up our bulk transmission and distribution system, some of it's over 100 years old. Other things, the big transmission distribution transformers that were built not for types of all the harmonics and reactive energy issues and everything else that are coming into play now as we advance that electrification, more electronics, more everything else. The discussion of HVDC switching systems for moving bulk power more economically with high voltage DC, things like that. Those were all part of the discussion. But the AI data centers apparently have taken us much further than we thought. So where data centers were asking for 10 megawatts on a service, and then soon 100 megawatts on a service, with the release of AI, we're talking about 100, 200, even up as high as a gigawatt per some of the discussions. Even Elon Musk's data center, it used to be you planned these 4 or 5 years out, all the work that went to it. The one that he put in recently, 155 megawatts, with the intent to expand it to 300 megawatts, occurred pretty much 122 days. So that's significant. The bulk grid is and local distribution isn't really prepared to handle it. There isn't even the generation for some of this stuff. So we're hearing about the opportunities to do, to reopen or go back into nuclear and a bunch of other things, all things that, are being discussed, but there are no answers yet. Basically, progress has exceeded the capabilities of the systems. Matter of fact, it was stated by one of the coordinators for transmission that they were used to dealing with 5% growth a year for a period of time. And with some of the new systems coming out, they're looking at jumping from a 5% growth to 200% growth in about a year without the lines or generation that exists. And then, of course, it wasn't just a concern about producing the energy, but what happens if one of these large loads just drops offline? Apparently, the amount of damage that could occur is significant. So, there's a lot more coming. My original intent was to see, what areas we could address in the power generation side with alternative energy, which was equally referred to as distributed energy, and then the certain turbines, but mostly solar and battery, as basically inverter-based resources. So that means a whole new range of issues, including a whole new band of harmonics that we really hadn't addressed in the past, because while they existed, high-order harmonics, they really weren't truly affecting power generation and end users to a huge extent. Now they are. Or now they will. And in some cases they are. We're seeing it in random machines that aren't even connected to VFDs having problems with their bearings based upon electrical discharge, grounding grids just being overwhelmed. And that was a discussion we had there, and it's known. Meaning that, I'm sorry folks, I haven't been screaming into the wind. This is known stuff. And while commercial entities and individual naysayers have been out there, these discussions are going on a global scale by the people who understand them. So sorry, Mr. LinkedIn or social media specialist, your arguments are moot. So these are real things. These are really happening. And just as I ran into something today on LinkedIn, a lot of people are screaming to the clouds about stuff and blaming everybody and pointing fingers and getting their egos out there. But I don't see them in any of the meetings. One person said, well, us commoners. And I go, well, if you look at my background, I'm pretty common. So, as an independent, I actually have a voice in here. Other people could be too. That's part of the reason I, put in the bit about, in our call, in the logo saying, doing what everybody else just talks about, because everybody keeps saying, nobody listens, well, yet I never see you. You're never there. If you want to be part of the solution, be part of the solution. Don't just bitch about it on social media and expect people to come running to you to soothe your ego. There's things that I'm involved in that it's taken me decades to get progression on those things. It's engineering is not, is a slow pace. Standards are even slower, even though they've accelerated them by requiring them to be updated every 5 years. I mean, right now, I just found out today, finally, the PAR is out for 519. So now I have to use my resources to see if I can get some input for some of the things we're observing. But that's going to require time and effort on my part. Not me throwing something out there in the wild and hoping that, somebody calls me up because my post was so brilliant. Sorry, And if you sit there and your response is personal insults, well, we really don't want you. you're not really going to be listened to, because egotistical BS when you're in a meeting. Sometimes I come off as having an ego. I know that. That's just part of my nature to come off like that. But I've known I can't have that ego when I'm in a room full of other egos. If I want to get people to listen, I have to work within the constraints of everybody's ideas, meaning I have to listen and do things. Did that during my time at SMRP. I reminded the members it's their organization. What do you guys want? And, implemented what the group came up with. That is what we need to do. And even with all these different areas, I wrote something and flew 23,000 miles and then got no response. Well, what did you do? Yell at them? Insult them? That I find that really convincing, because the response was really interesting. So, I run into that a lot. I'll see something, I'll say, hey, have you tried doing this? Oh, no, I'll never get a chance. Well, great, you gave up. That's why people like me get to make decisions and you don't. So, I'm not a mega corporation. I'm a small business. I choose to make those decisions. Hence, I accepted a number of requests to volunteer. On my dime, of course. They're volunteer positions. I don't get paid for it, and often it has no impact on my business. But I would like to see those changes. Therefore, I take the time and energy to do it, and because I think, personally, it's for the greater good. I could be wrong. Don't know. We'll find out. But, I've made mistakes before and got involved in things, and they were disasters. It's like nobody cared. And then I've been involved in things that have had major impacts on a global scale. But it required the time and energy to do it. That's why we take a chunk of our profits and sink it back into volunteerism and research. So, that was my soapbox. Let's get into some of the things that we have going on from the part that funds the stuff that I do. So there's a couple of things that are going to happen, especially in CIGRE. I'll announce those once they're implemented, because I have to propose and wait for people to accept, and that takes time. And then all the projects take a couple of years. But I see a lot of people, especially in ESA and MCSA, trying to come up with their own definitions for things when there's already definitions out there from an engineering perspective. And they're solely commercial. A lot of them, I watch them take data that we've spent years researching, going out, grabbing our papers, and then trying to produce a product. And I suppose they get surprised when they find out that I don't release all of my IP publicly. So, suddenly they discover that, oh my gosh, why isn't it working right? Well, because you didn't work with us, you went off on your own, you read my book and thought that was everything you needed, or you read a bunch of my papers and thought that's everything you needed. No, I put the ideas out there, and if you had a half a brain, they'd work. But neither here nor there. Had to throw that in. Sorry, guys. Find it frustrating when people come out and they say that they're this and that, and then they're not, and it damages the industry when there are legitimate companies out there that are doing great things, and those companies tend not to be investor owned. I know MotorDoc sure isn't, nor are our partners. So in any case, let's get into the first one. So I'm going to take a look at data. I believe I also have this in Empower. I do, as a matter of fact, because I just opened it in the Empower. So let's go ahead and take a look at some data. Don't need to see everything in my thing. So this is data on what is it? 1150 horsepower, slow speed, 4,000 RPM, 166 amp Not sure what didn't see a. So this is version 9 that we're working with here. So a couple of changes right up when it opens up. First thing it did is it grabbed as close as it could to what it saw as the actual speed. It looks like this is almost, if not synchronous. So you can see a peak here. Chances are that's related to the speed, but that would bump me down here. So let's see. It's not a synchronous motor. It would be 720. So 711 RPM is an induction machine. And there it is. We do have bearings involved, and you can see inner race, outer race, cage, and ball spin is here. So a lot of this is very similar. I haven't seen the machine, so we'll assume that's correct. If I put in hours, then that would relate to the energy and emissions analysis bit. So let's say it runs 24 hours per day. And let's make sure, here is the other thing, is the setup options have definitely changed. Scheduler is even built in here now, so I have to be careful, because if I do anything here, it'll launch the scheduler on my computer. I learned that. So it was restarting, every time I started my laptop, it was restarting EMPATH, which I use a lot, so it really wouldn't have mattered. But all of my settings, everything else, still here, just organized a bit differently. Let's grab that. 10 cents per kilowatt hour and 0.699 metric tons of CO2. I have vibration analysis built into my system, so when I upgraded, it kept everything. It just moved right into the new version. So all of the other stuff is there, including the alarm settings. And these are general by overall machines. You can tighten things up, loosen things up, especially if you're doing continuous monitoring. I always set the minimum load to 5%. Not clear why, there was a big push by one distributor to keep it at 25%. So for whatever reason, the programmer keeps it there, but we normally test motors that are unloaded when we're at repair shops, sitting on the thing, regardless, you've heard me talk about it before, regardless of, I found it interesting, the pushback from certain industries, including the repair industry. Then I realized most of them sell vibration services. They definitely don't want ESA involved. I jokingly said once, vibration's dead. And with a lot of cases, ESA is faster, cleaner way of getting data, and sees far more all at once. It's not it is definitely something that works along with vibration analysis, more so than replacing vibration analysis. But I even, there's the ESA Trade Association started having articles published, wanted to push into standards that you can't use electrical or current signature analysis in a repair shop. Then I look who was involved, and I go, oh, makes sense, strong background in vibration, don't quite, everybody that keeps doing that, no freaking concept whatsoever. The latest article, I read the article and I went, this guy had no freaking idea of what the data meant. None at all. Just and went in there and pretended he was an expert. A vibration company, of course. Heaven forbid we come along and we're a bit of a threat. The new technology is a bit of a threat. Now, mind you, we've got those out there that the equipment they put out is a freaking joke. And they don't help us. They don't help the industry at all. But, what can you do? So anyways, it picks all this stuff up. Let's see what it analyzes. This is well below the threshold I put in for alert for, unbalance or misalignment. you can see that based on the fact that there's a little bit of a band on either side of here to alert you to stuff, it's there. Could it have actually gone on top of that? Sure. I have a feeling that right here we're looking at a pole pass frequency. Anyways, I'm going to pause this just because whenever I analyze it, the Camtasia thing takes up basically a lot of memory, a lot of RAM. So hold on. Okay, and there we go. So just took a little bit. It identified a low power factor. Says there's a light load on it, which is possible. We'll see that in a second. Could be the CTs were set up wrong. Here, let's take a look. So when they took the data, they didn't rotate it, so it looks like the phases are rotated a little bit. So real power is very low, partially because of a very, very low power factor there. Current should have been showing a much higher percentage, but we're all right. We're good. Not much of an impedance unbalance, things like that. Operating frequency, running speed, so there's the peak there. There are bearings in there, and looks like they're okay according to this. These are the harmonics. I've got it set to the 15th. It'll go out to 50th, and then voltage and current harmonics are very, very low. Let's see what it did kind of calculate as the losses. Okay. Harmonics, it claims a fairly high loss. Let's come down here on balance is low, and then other peaks. So most of this has to do with just a lot of noise on the line. So not too concerned about that. Let's go here, take a look at torque. It's hanging up a bit because of this here. Okay. This is the actual air gap torque. Let's zoom in and see if we have something going on, because those are pretty... Okay, so I probably have something going on here. Let's get out of here, and we go to next to the high frequency data set. Let's see what it looks like. Now, this is the second time I've used this, and I'm about to use version 9 to go through about 30 odd wind turbines in order to evaluate them. Let me pause again so my voice, I don't get dub voice too much. Okay, so here we go, and then let's change the layout a little bit, because it's pretty clean actually. So what's happened is I'll sometimes drop down here, so I usually type in a -120, and that'll bring the noise floor up so I can see it. Okay, there we go. Looks like there must be an inverter somewhere. It's set about 1800 or so, and then there's it's possible, the hump, and then a little bit of a hump out here. So some type of electronics is definitely affecting the system. Whether it's associated directly with this machine, I don't believe it is, or somewhere else. Now we did have the rotor bars and stator slots in here. So let's have it take a look at some of the peaks, get the power harmonics in, and then let's take a look and see where static eccentricity is. Okay, and then the next bit is I want to take a look at stator mechanical. So all of this is down here. So let's zoom in here. We can ignore all this stuff. It's one of the nice things about electrical signature analysis. You don't really get, unless it's electrical in nature, mechanical conditions and similar usually don't have harmonics. So this is both for current and electrical signature. Had somebody suggest motor current signature. Oh, that's right. It was that other that other article. I swear. It's like, motor current signature analysis, can't see anything, but you can with electrical signature analysis. It's like, wait a minute. Current signature analysis is what you use in electrical signature analysis to measure the load. And if you actually knew what you were talking about, you would know that. So current signature analysis alone, like the Empower, the only thing I don't get is this spectrum down here. I get this. So, but then again, like I said, you got to know what you're talking about. And yeah, I'll insult the idiot all day long. Here we go. No, so this is what's important. Okay, so here's the peaks there. So yeah, my speed must be off by just a tad, because you can see here it is. So it may have called static eccentricity, which means, I've got a slight one time and I've got static eccentricity. This you'll find that we're building this into version 1.1 with the Empower. It's going to take a combination like this, and it'll say, soft foot, misalignment, and soft foot. So definitely see something there, especially seeing as the peaks are higher in current than they are in voltage. So if I hadn't, I wouldn't know. ESA has that capability of, the voltage signature helping me identify whether or not it's the system I'm looking at in current signature or it's somewhere else. So I lose that one little bit in current signature, which, we definitely have a price difference between an EMPATH and an Empower for that reason. So let's see, and then I can take a look at dynamic eccentricity. And it's possible that it's got a little bit of orbit. Yep, definitely a little bit of orbit. So I have the peaks there. So it's shifted a little bit. Some of that, because this is taken with CTs, especially if they're older CTs, some of the shifting I'm seeing, it could be a little bit of drift as we go out. And we talk about this when we teach classes. I don't hear it from others, but, that's because they probably don't have the experience. So we're there. And yeah, I've been a little aggravated lately about some of the crap that comes out. So pardon my my WTF moments. I'm getting older. I'm not as tolerant of dumbassedness. Static. Okay, so this is stator electrical. This would indicate breaking down insulation systems and so on. No, nothing there. And then winding, not wiring, I've got to remind them of that. Had that changed from winding short to winding stress. Very, very important. That was one of Motor Doc's discoveries. The work in the past by Bill Thompson and everybody else related primarily to, so there's a little bit going on. You can see it digitized a little bit here as far as data goes. That sometimes will happen when you've got really clean data, or smoothed out because the CT, CTs and PTs will eliminate some of the lower frequency stuff and leave the higher frequency stuff. So when I see this, I know I might be missing some information, but you can see, small peak here, teeny peak there, small peak here, teeny peak there, small peaks there, small peaks there, and they're not aligned with the line frequency. So yeah, there's some stress going on, probably due to a few things. As a matter of fact, let's take a closer look at, in particular, what the waveform looks like. I'll pause it. Okay, so here we go. Voltage and current. Let's zoom in a little bit so we see what the waveform actually looks like. You can see voltage, there's something going on because I got something riding up there. That would explain all the peaks over there. Yeah, so I've got some kind of phase thing going on. I suspect it's the way that... no, that one phase is definitely off. So it could be a low power factor due to some type of voltage unbalance. That looks significant. Let's see what it looked like. Okay, so not clear. It looks like possibly something wrong during data collection, because I've got 2300 volts and just under 4000 volts here. So I think that was more along the lines of an error in data collection. So not horrible. I'm still able to analyze things because the analysis actually occurs off the waveform, and the voltage isn't really like that. Otherwise, current would be horrifically different. So a little bit of issue on data collection there. I'll have to talk to the repair shop that sent me the data. So so there we go with that. Some idea of what's going on. So I'm going to turn this off so that we get some of our RAM back. And let's take a look at the Empower. First off, I like to have this up just so you can see that stuff is happening. So I left, usually when you do programming, you shut down this window in the back. It's called windowing. So you shut this down so you can't see anything, but because of the way we developed it, it does a lot of work, and then it produces the results instead of a step at a time. Found that allowed for more accuracy, but due to the delay, because it could take, if you don't know the speed, it could take a couple of minutes for it to process. Okay. Up, there we go. Oh, yeah, sorry. So here's the same thing. So let's go ahead and we'll select the WAV file. Then it should ask me for the nameplate. There it is. And now it will populate. So it had taken 120 seconds data. We chop off the first 10 seconds. And then when we're waiting for it to do the analysis, I'll show you the new feature that we're working on. It'll be a separate software initially for version 1 users, and then we'll incorporate it into the total program. Just don't want to disturb the program as it is while we're working on a lot of other capabilities. Wasn't intending on it, but I went ahead and purchased some rights to it. Now these warnings down here are showing up because, again, everything moves much faster when I'm doing the other. So, okay, so here we go. Here's our data. I've looked at it before. You can see some of the data here is a little heightened. So right now, I've moved these. I've adjusted these manually. Now, in the final version of what we're working on, I won't have to do that. And by the way, when you save the motor, so this is the calibration number for the machine the data collector that was used. So when I go in and I'm using mine and I open it up, it will populate it with my number and so on and so on and so on. So when I open the software up, it defaults to my calibration number or sensitivity number, and then so on. So let's make sure that we have everything set here. Yep, that looks about right. I'm not sure why this is 10 milli. Oh, yeah, because that was a setting on the thing. I think we'll find out if he had that. Yeah, that's right. Okay, no other equipment, even though I know it's a pump. There it is here. Bearings were already entered. number of rotor bars and stator slots. This is going to be the energy analysis or losses by defect. Came up with an algorithm that does a great job at estimating it. Sometimes it goes way off the chart, but mostly I can equate them exactly to the EMPATH. So that's there. And then here's the watts losses for each thing. So some numbers will be really, really high, of course, and so on. But let's come back here, and we are going to see, I told you, look at that, 95 amps. So let's go ahead and we're going to allow it to auto-analyze. It's going to go in and it's going to look for the running speed, which should be about 11 or 71, somewhere around here. In here, there's probably a peak there, but it's going to work on this side, and we'll see what comes up. You see it kind of a flat. That has to do with a lot of noise sitting there. So that's actually a whole lot of peaks on the way out. So the noise floor is actually going to be somewhere around here, because I have it show, or somewhere, I'm sorry, we're down around here, but I set my alarms above this floor, this physical floor here, so that I get my 5 and 10 dB above the noise floor. So let's go ahead and we will click on Auto Analyze, and it's popped up and you can see it's doing its thing. In the meantime, I will show you our other little treat, what we're developing. It will not look exactly like this when it's done, because we're also going to have rotor bars and stator slots that you can pull up as well. So you'll be able to run this. It is a license, and its license is associated directly with the other license. So if you're a present user, as soon as we release this, probably in about a week, it's going to pull off of a reasonable database of machines. So I've got some temporary in here. And basically, I'll be able to select a bearing, select the information, and then there's my stuff. So this is just as helpful with vibration as is with current signature. In version 1.1 or 1.2, haven't decided yet, you would be able to select this when you select nameplate information or any other bearing information like the driven equipment, and it will automatically populate where you are. So that's the big one here, and the same thing with rotor bars and stator slots. So I'm going to pause this while it's running. Okay, so here we go. Now, don't get me wrong. I mean, there's some that I follow. There's some university work. There's some other stuff that that is promising when it comes to ESA and MCSA. I'm not a fan of modeling, etc., other than for the research part. But really, the practical side is more important in any research. So I've seen a few that look promising from the modeling standpoint, and we play with those too, but we test it before we apply it and make sure it's valid. Also, when it comes to things like machine learning and AI, obviously, if you followed along, you understand how I created this. So I'm a believer in machine learning and AI. I used to teach it at a university level, and I just think that people are overhyping things, and some of the conversations even last week were pretty scary when there were suggestions that we should allow AI to make overall infrastructure decisions, forgetting things like 2003 when that Northeast blackout, which after the calls of blame it on Canada went away and the research was done, the RCFA, they discovered that it was a lack of, tree maintenance, sagging lines because of heavy loads, in particular with AC, and and a software package that made the decision not to inform somebody that these conditions were occurring. It wasn't a tiny little third-party software either. It was by a major corporation. So, all of this stuff is biased in one way or another, and that bias can have a negative impact. So let's see where we end up. It is working still on some of the FFTs. It's running a little slow again because of this. Hopefully my voice isn't lagging by too much right now. It's definitely going to, I think. Let's see where we are here. As soon as we start seeing it start talking about kilowatt, then we're good. So I'm going to pause again so we don't get out of sync too much until it populates this. Okay, there we go. So came up with okay, that's actually very good. That's about where we were with the EMPATH software. So I can suggest that that's probably a good set. Let's take a look and see what the peaks look like where the speed was selected. So very low. There we go. And this is a bearing. So pole pass frequencies kind of blended in a bit. So that is not true there. And then it says stator electrical and stator eccentricity. Those are two conditions that existed in the other one that hadn't shown up. So let's go out here, and sure enough, there's all of those peaks that we were talking about. So the additional ones here, that's stator. You can see all these peaks here. That's electrical noise. Let's take a quick look up here and see what this kind of looks like. Okay, no, not too bad. So I've got all of this noise here, and that's why the noise floor looks so high. Not horrible there. And then let's see what this looks like here. So that's going to tell me about different peaks. If I come in here, it's going to give me a really, really, really huge number. So that pole pass frequency one, that is not accurate. That would be, wow. Yeah, that's not accurate. So that's a noise thing that got hung up there right to the left, and we did see that in the other one. So I would have to subtract that value from the rest before I move forward. So let's go ahead, and we're going to take this out, and we're going to subtract 113 5195 357 minus 113 2245 0.066. That's going to give us 2950. So we'll get rid of this up here. Just have to highlight it, delete it, and we're going to change this to 2950. If I did this right, I think I built this into the software to allow me to do this. We'll just say 0.3. Okay, so once I have that, let's go ahead and hit analysis. Yeah, that looks more like it. So yeah, so it took the number I put in here. It's supposed to process it as total watts. Kilowatt hours 1701. Okay, so it multiplies that by the number of hours of operation, which back here, I'm sorry, nameplate 6,000 hours. So times 6,000 hours, and that gives us 12 tons of emissions at about $1,800 of potential savings in a year for going in, taking a look at things. Things I'll want to look at here so the stator slot and the rotor bar related issue here, this is the high frequency on. That's a lot of energy. So that's not a full kilowatt. This one is really close, but that's 782 watts, and that's 991 watts. So that's basically a kilowatt related to the rotor bars. So let's that would have to do with all this stuff here, and let's zoom in and see what's going on. So stator is the one to the right, rotor bars is one to the left. Okay, so small bumps for each one. So small bump there and small bump there. Let's yeah, so there's those peaks. So they followed along right with what we saw in the EMPATH. So looking at this, that tells me my final analysis was right. So definitely not a rotor bar issue, but definitely some stator electrical and static eccentricity, meaning that I've got some electrical issues going on and I have eccentricity. Now, it did not find the winding stress. That signature didn't pop up, but that's about it. No bearing issues at this point, although it does look like I'm closing in on some lubrication stuff due to the volume. And when I get 3 digits worth of watts in a bearing, it's definitely going to be an issue. So let's take a look at that again. So here we go. So outer race 114, that is not a lubrication thing. Although a little bit of lubrication there. Yeah, definitely with the ball. So, and then opposite drive end, definitely. So I would suggest to the company to lubricate those bearings and then go from there. But there is definitely some stuff going on. 221 watts having to do with most likely misalignment, because I definitely have saw foot. That would be the, yeah. That would be the rotor bar base. That would be that static eccentricity. And that's about it. So welcome to some updates that'll be coming out this upcoming weekend, especially those who have the system already through the email system we have set up. You'll have this as a download. It will install directly into where you installed your Empower software, and you'll be able to look up bearings and rotor bars and stator slots instead of having to hunt it down. Originally, that's something I wasn't going to do, but with the volume that we've moved, I think it would be a nice benefit to have. Something that we had stated we weren't going to do, but why not? It's to everybody's benefit. With that, thank you very much. I hope you enjoyed my little bit of a rant. There was a lot going on. Some of it was frustrating this week, obviously, especially when it came to some of what we're running into with AI, machine learning, bad information in ESA and MCSA getting out there by people who don't know. There are plenty of us in the industry who do know. Some of us take different approaches. I watch what other people are doing. We try it out, see if it works from our perspective in the field. So this week I'm going to be in the field. So next week we are going to discuss some of those results. It's going to be a second go around on a lot of the stuff where a lot of things were corrected from exactly a year ago. So this will be exciting. Real applications, very small to larger machines, vertical, horizontal, some VFDs, pumps, you name it. We've already done the data, so I'll be able to go through some of that next week. Have a fun one. Talk to you soon.